My name is Stephanie Dempsey. I'm a math coach at Northwest Middle School, and today I am going to work with you on some of the packet that came with the KCS at Home Summer Edition. Today we're going to be looking at 6th grade math, specifically ratio reasoning. If you look in your KCS at Home Summer Edition packet, we are going to be looking at the section 2 in 6th grade math about ratio reasoning. We have 4 different activities that we are going to work on today. The first one is unit rates. Then we have ratios, rates, tables, and graphs. Next, we will look at solving problems with proportions. And last, we will look at understanding percents. So let's get into it. The standard that covers everything we're going to be looking at is as follows. We are going to use ratio and rate reasoning to solve real-world and mathematical problems. So this will be broken down into 3 different pieces. The first is that we are going to make tables of equivalent ratios relating quantities. We will also solve some unit rate problems that include those involving unit pricing and constant speed. Lastly, we'll be finding percents of quantities as a rate per 100. Those are the standards that are covered under this section today. A couple of vocabulary terms I want to go over with you all very quickly. The first one, ratios. We need to know what ratios are. They are going to follow us all the way through the rest of middle school and high school math. A ratio is simply a comparison of 2 quantities. We could be saying 3 apples to 2 oranges. We could use a colon and express those numbers as a 3-to-2 ratio. We could also write 3-to-2 as a fraction. All of these are different ways of showing a ratio. A rate is simply a ratio that shows the relationship between 2 different units of measure. So you might have miles over hours, or the cost in dollars over pounds. You might have how many texts are written over how many minutes it took to write those. So that's simply the difference between a rate and a ratio. All right? A unit rate is simply a rate that we now have written in the lowest terms. In other words, miles per 1 hour, or the cost for 1 pound, or how many texts written in 1 minute. So these are the skills that we're going to be using the most as we work today. We will also need to make sure that we remember and understand what equivalent ratios are. So equivalent ratios are simply 2 or more ratios that express that same value. You can find them by multiplying or dividing both quantities in one ratio by the same number, as you can see the example at the bottom of your screen. In the bottom of your screen, they took the fraction 2/7, or the ratio 2/7, 2-to-7. And if you multiply both the numerator and the denominator by 2, you come up with an equivalent ratio. 2-to-7 is the same thing as 4-to-14. And then conversely, right beside that, we have another ratio, 8-to-24. This one, we were able to divide both of those numbers by 4, and we came up with an equivalent ratio of 2-to-6. So those are the vocabulary terms that we're going to see and use a lot as we continue to work today. If you will, look in your packets at section 2, activity 1. This is where we are going to start. So first off today, we are going to just start with finding unit rates. Now, your example and your teaching part in your packet gives you the example you see on your screen. It talks about how you can find the unit rate, and it gives Karen taking a bike or biking for 35 miles in 7 hours. And to find the unit rate, you would just do 35 divided by 7, and you get 5 miles per hour. And then there's an example problem where we try to find the best buy out of 3 different items. I'm going to walk you through a couple more problems so that you have a couple other examples of how to solve these types of problems. All right? So, a 5-pound bag of cat food costs $11.25. Our question asks us, what is the unit price of the cat food in dollars per pound? So I'm trying to find the unit rate. I've set up my ratio first so that I remember the right way to set it up. I'm going to do dollars over pounds. So in our problem, we know that a 5-pound bag of cat food costs $11.25. So I set up my ratio that way. Now I'm trying to find the unit rate. So I want to find an equivalent ratio with 1 in the denominator. So 5 divided by 5 is 1. Now I have to find out what $11.25 divided by 5 is. So I get started. 5 goes into 1 0 times. It goes into 11 2 times. 2 times 5 is 10. We subtract, we bring down the next digit. 5 goes into 12 2 times. 2 times 5 is 10. Subtract, you get 2. We bring down that last digit. 5 goes into 25 5 times, with 5 times 5 equaling 25. We have used all of our digits. We have no remainder. So the unit price is that 1 pound of cat food costs $2.25. All right, that's how we do that problem. A similar problem. We've got 3 wholesalers. They're having a special deal on chicken. Wholesaler A is going to sell 10 pounds of chicken for $40. Wholesaler B is selling 15 pounds of chicken for $45. Wholesaler C is selling 20 pounds of chicken for $50. The question is, which wholesaler has the best price? To figure this out, first thing I want to do is set up my ratios all the same for all 3 businesses. Wholesaler A, $40 for 10 pounds of chicken. Wholesaler B, $45 for 15 pounds of chicken. And then lastly, we've got wholesaler C. And wholesaler C has 20 pounds of chicken, which I miswrote, so I fixed it, 20 pounds of chicken for $50. Now, to find which one is the best price, we need to find the unit rate. All right, so I'm going to set up all of these problems with a unit rate of 1 pound. And then I'm going to find equivalent ratios. 10 divided by 10 will give me 1 pound. So 40 divided by 10 gives me $4. Wholesaler B, 15 divided by 15 will give me that 1 pound. So $45 divided by 15 gives me $3 for 1 pound of chicken. Wholesaler C, we would do 20 divided by 20 to get 1 pound, and then $50 divided by 20 is $2.50. So if we are looking for the best price and we look at those unit rates, you can see that wholesaler C with a unit rate of $2.50 per 1 pound of chicken is the best price. So when you go and do your independent work that it looks just like this, you can go back and look at the section of the video where I just did some sample problems, or look at the teaching part that is at the top half of your page, section 2, activity 1. Now, let's move on to the next activity. Here we have activity 2. This will be on the next page in your packet. This one is about ratios, rates, tables, and graphs, and we're going to try to put all of that information together. So on the bottom corner of your screen, you'll see the teaching section that you have in your packets. What I'm going to do is work through a very similar kind of problem right now with you. So let's do that. All right, so we've got a table and it shows us information about the number of sweatshirts sold and the money that is collected at a fundraiser for a school athletic program. It's given us a table, and the first question wants us to find the rate of money collected per sweatshirt sold. That means we are looking for the unit rate. We can't fill out this table the rest of the way unless we find the unit rate. So I look at the one that I have, and I know that it costs $60 for 3 sweatshirts. So I want to try to find my unit rate from that. So that means I want to know per 1 sweatshirt. So 3 divided by 3 is 1, $60 divided by 3 is $20. So that means every sweatshirt costs $20. That's our unit rate. All right. Next, we're told to use that unit rate to complete the table. We can use multiplication to do that. So if we know that we sold 5 sweatshirts and each sweatshirt cost $20, we do the math and we find that 5 times $20 equals $100. So we'll put that in our table up top. And then we'll continue on in the same way. Next, we sold 8 sweatshirts. So 8 times 20 gives us $160. And then we skip over to the end and we've got 12 sweatshirts times $20 per sweatshirt, and that equals $240. Here we were given the money collected. So if we take $180 and we divide that by the $20 each sweatshirt costs, we learn that we actually sold 9 sweatshirts. So that's how we fill out a table using our unit rate. All right, now we're going to skip question number 9 on my page because that one's not what we need to help us. What we're going to do is look at the next one. It says to write all of the information in the table as ordered pairs so that we can then graph it. So let's look. Here's our table. Our x-axis, the horizontal line, is going to be the sweatshirts sold. So that's going to be our first number in our ordered pair. The second number in our ordered pair is going to be the money that's collected. That's our y-axis. That's going to be what's going vertically up and down on our graph. So as you can see, I'm taking all of the information in the table and I'm turning it into ordered pairs. Doing the last one right now. And then we're going to take those ordered pairs and we're going to plot them onto a graph. All right, so let me move the graph where we can see it a little bit better. It's taking me a minute to get there. And there we go. All right, so first off, we have 3 sweatshirts cost $60. Oh, I went too far. Ignore that mark on my graph. We're going to pretend I did not do that. And we're going to move right there. 3 sweatshirts cost $60. The next ordered pair, we had that 5 sweatshirts cost $100. Then we did 8 sweatshirts, and 8 sweatshirts was $160. 9 sweatshirts was our next ordered pair, so 9 going up to $180. And last we had 12 sweatshirts. And then we go and we find 240 on the vertical. And you can connect all of those points if you would like so that you can see how they are make a straight line because they are all increasing by the same amount. But now let's look at another couple of questions. They're very similar to ones that you would have. It says, how much money would be collected if 24 sweatshirts were sold? In order to do this, we're going to go back and we're going to use our unit rate right here where we know that one sweatshirt costs $20. So if we have 24 sweatshirts, we're going to multiply that by 20 to find out how much money was collected. And that will equal $480. All right, last question. It asks us if the point of 5.5, which is 5.5, and 110 makes sense in this context. So I want you to think about this. That 5.5 is 5.5. That means they're saying that we sold 5.5 sweatshirts. I don't know about you, but I can't buy a half of a sweatshirt. I don't think I even want to buy a half of a sweatshirt. So thus, in this context, 5.5 does not make sense because we can't buy half of a sweatshirt. All right? So I hope that helps you understand why that point does not make sense in this context. All right? Now, let's look at the problems you're going to do. Here are the problems you're going to be completing. Hopefully what we walked through right now will help you because I gave you examples of how to solve exactly these same type of problems in the last slide. All right, so hopefully you can go back and look at those and it'll help you and you will feel like a genius. All right, now let's look at the next activity. All right, next, we are going to look at solving problems with proportions. All right, on the bottom of your screen, you should see section 2, activity 3, solving problems with proportions. They give you a couple of examples, and now I am also going to walk you through a few examples myself. All right, so first problem. We've got that the members of a PTA are ordering pizza for a meeting. They plan to order 2 cheese pizzas for every 3 pepperoni pizzas that they order. How many cheese pizzas will they order if they order 15 pepperoni pizzas? So they've given us a ratio. They have said that we're going to order so many cheese pizzas for every pepperoni pizza that we order. All right, so let's look at what they told us. They said we would order 2 cheese for every 3 pepperoni. Now, our problem tells us the information that we are going to order 15 pepperoni pizzas. So we want to know how many cheese pizzas we're going to order. So we think about, well, we make an equivalent ratio. 3 times what gives us 15? That's 5. 2 times 5 gives us 10. That means that we will order 10 cheese pizzas for the 15 pepperoni pizzas. Now let's look at another problem. In this problem, we've been given this. If 4 gallons of milk cost $16.76, how much would 7 gallons of milk cost? In this problem, rather than using equivalent ratios, it would be much easier to find a unit rate and then multiply. So 4 gallons of milk costs $16.76. To find the unit rate, we're looking for an equivalent ratio that has 1 as its denominator. So we want to know how much 1 gallon of milk costs. So we need to take $16.76 and divide it by 4 as well. So 4 goes into 1 0 times. 4 goes into 16 4 times. 4 times 4 is 16. We subtract and get nothing. We bring down the 7. 4 goes into 7 1 time. 4 times 1 is 4. 7 minus 4 is 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. And when we subtract, we get nothing. We have no more digits to bring down. So that means that our unit rate is $4.19. All right, but now we're asked how much would 7 gallons cost. So we're going to multiply. We take our unit rate and multiply that times 7. 7 times 9 is 63. 7 times 1 is 7 plus 6 more is 13. And then 7 times 4 is 28 plus 1 more is 29. We have 2 decimal places in our problem, so we're going to move that decimal over 2 places in our answer. So 7 gallons of milk will cost $29.33. All right, I have one more example for you because you have a problem like this in your independent work. So I want to make sure that you are understanding how to do this on your own. This problem says that a person on a moving sidewalk travels 21 feet in 7 seconds. Okay? And then it says that the moving sidewalk has a length of 180 feet. And we want to know how long it's going to take to travel that 180 feet. Now, I don't know what 21 times something would equal 180. So I'm going to make an equivalent ratio by taking my 21 to 7, dividing both of those numbers by 7, and I get 3 feet are traveled every 1 second. So now, if I want to find an equivalent ratio using 180 feet, I'm thinking 3 times what equals 180, or 180 divided by 3 equals 60. All right? I want you to see how this all connects. Okay? We took 3 feet and we figured out that if we multiplied that times 60, we would get 180. So I multiply 1 second times 60 and I get 60 seconds. So how long will it take to move from one end of the sidewalk to the other? It will take 60 seconds. I hope that helped and made sense. In your work, You have two problems that are very much like the first couple that I showed you. The last one, you're going to have to do something very similar to what I did in that last example. You're going to have to find an equivalent ratio, and then you are going to have to figure out what you need to multiply by to get the new drawing dimensions. Okay? Now, we have one more activity to look at this afternoon. All right, so activity 4, now we're just going to review understanding percent. All right, you have some very simple problems today. The teaching part that is in your packet for activity 4 is very simple. We are simply taking some percents, we are turning them into fractions, and then we are turning them into decimals. So I wanted to walk through a quick problem with you to give you another example. This one says that Lorenzo spends 35% of his budget on rent for his apartment. We're asked to write this percent both as a fraction and as a decimal. So let's see what that's going to look like. If we start with 35%, first we're going to want to try to turn that into a fraction. Then we're going to try to turn that into a decimal. Okay? First thing I want us to think about. When I think about percents, I know that percent means per 100, all right? And so for me, that means the same thing as taking that number that is the percentage and writing it as a fraction over 100. So 35% is the same thing as saying 35 100ths, but I need to find that in its simplest form. So if I divide both numbers by 5, I end up with 7 20ths. Now, to take that same percent, 35%, and turn it into a decimal, start with the fraction, 35 hundredths. Now, if you remember your decimal place value, let my video catch up with my talking here. If you remember your decimal place value, hopefully you will remember that hundredths is actually one of the decimal place values. So if I scooch my paper up right here, you can see that if we've got a decimal in a number, the first digit to the right of that decimal is the tenths place. The second digit is the hundredths place. So if I want to write a fraction that's given to me in the hundredths as a decimal, I'm going to write it 2 decimal places past the decimal. So I just simply fill in those blanks, and I've got 35 hundredths written as a decimal. I hope that helped you understand how to do that. Your problems look like this. You have a few percents, and you simply have to write them as a fraction in simplest form. So I showed you how to write them as a fraction, and then you simplify it if you are able to by dividing both the numerator and the denominator by the same thing. The other piece is that you will write each percent as a decimal. And I also showed you how to do that. You write it as a fraction first that is over 100, and then you are going to simply turn that into a decimal that goes to the hundredths place. All right, I want to thank you all very much for joining me today. If you have any questions at all about this lesson, please email me at the email listed below, and I hope you are staying home and staying safe and staying healthy, and we will see you in August.